Hello everybody, and welcome back to the Moshix mainframe channel. This is Moshix, and you know that we have set up a BITNET network, a BITNET compatible network which I call HNET, and on that network we have all kinds of services, such as, for instance, weather Paris, and all these commands will be sent to a server which I have set up. I called it that node, I call it relay, and relay will get all these commands and expose all these services, and then answer to anybody who's connected to the network. And so the way I've done this is that I have set up a server, it's a Linux server. And this Linux server is connected both to the HNET network over the network job entry emulation, as well as also obviously to the internet. And because it's connected to both the internet and to the HNET network, it's able to process these commands and fetch the real-world data, real-time data from the internet, and provide it to the users on HNET. Such as done here, relay weather Paris. In this case, it will send these commands to the relay node, this machine here. There it's going to get processed, and it provides an answer back here, Paris 48. So today we're going to write a chat server so people can connect and send commands to the chat server and get back and whatever people write is going to be sent to all the participants in those chat. People can log on, log off. So let's get working on it. I've thought what language I could be using for this program, and it could be done in C, obviously. It could be done on Rex on Linux, many other languages, but I've decided to do it in the Go programming language because it's very versatile, it's powerful, it's almost as fast as C, or people say as fast as C. I'm not going to start a religious war over that here. And very, very portable, and has a lot of features in it that make it useful for this kind of purpose. And since this is not going to be a very large program, I thought I'm going to go and do it in Go language. So let's get started. So again, this is going to be very simple in the first incarnation. There's going to be just a couple of commands. One is going to be /logon to announce yourself to the chat server and be added to the list of distribution, /logoff to get off the list, and then maybe a few service commands. So in Go language, I already know that I'm going to be needing the main packages such as time, FMT, OS, because I will have to issue operating system languages to call the send command, which sends a network job entry command to all the participants. Receive all the messages from the network job entry system through a pipe. And of course, the most important thing is the structure of the data structure. I always start with that, and we're going to have the user at node as one item. So which user at which node as one item. What was the last message the user sent? Because I want to have a loop detector. A loop would be a message that keeps going around all the time because the user is logged out. And what is the timer for that particular user that the user desires, which we're going to implement later. And then when was the last activity, so I can log out the user after an amount of minutes if the user has been inactive, so as to avoid sending messages to users who have already logged out. The thing I like a lot about Go language is this map. As you can see here, map is an index structure. Basically, it just you can define what is the index item, and then I made the structure above the user structure that I just mentioned becoming the indexed structure that goes along with the index. So that is a very simple way to have a dynamically growing and shrinking structure or array without having to do memory allocation and that kind of stuff, since Go language has a garbage collector. And this list is not ever going to be very big. I don't expect many thousands of users. on this chat server. We try to open the pipe and give the appropriate command if we cannot open the pipe structure within the operating system. And if we do, then we just announce that we have opened the pipe, and then we do a buffered IO read from the pipe. Read command is past just the line that came in through the pipe, and now we need to do several things. First, we need to, since the index of the map is going to be uppercase only, I will have to define the same message to be split between the user part and the payload part, both in mixed case and in uppercase only. And I decided that I will have to take since the whole thing is going to come in as one item in the pipe, which means the user, add, node, and then the message itself, I needed to decide on a separator between the user node and the message. In this case, the semicolon is the separator, and so now if I do that, I will have in one part of the result of the split is going to be in S0, and the message is going to be in S1. And this way I know which part is in which part. I separated, basically I parsed the input, just a very simple parser. And then the other thing is that I wanted to make the user part, which is user at node, be uppercase, because as I said, that's going to be put in the table as the index portion of the table. So there's very simple commands for this in Go language, and very easy to look up. When you look up things for Go, always type Go lang, because Go itself is too general term for any search engine. Alright, so here, once we have the input parsed correctly, it's just a matter of having a switch structure which processes the input. Either it's a log on or it's a log off. We can have a help maybe at one point, a who to show who's online, and maybe stats, some simple stats. And if it's not any of those, if the payload is not any of those commands, then we just assume it must be a message to be sent to all the others. And it's not a command that it must be a message to be spread out to everybody, to be distributed. Then before I send it, broadcast it to everybody else, I want to be sure that the sender of this message is actually logged on. And that's what we're doing in this few lines here. We check if the sender of the message is logged on, is in the table that I call in the map, which I call table. If the person is in the table, then we call broadcast message. If the sender is not in the table, then we just give her back a message saying you're not logged on, please log on. And here you can see how we execute commands from within the underlying Linux operating system. I know that send is stored in user local bin send. And of course we also update the message count, so that because that is also a message. And now we do the implementation of the functionalities from the switch structure. Adding users and deleting users, just looking them up first in the map, in the unordered structure. And sending the message. So this part that I just highlighted should be taken out and become its own function, which I will do. Now the broadcast function is the one that's most interesting. So add user, delete user, etc. is simple. Also the who command, that's all simple. Just we loop just through the table and do what we have to do. But the most important function is the broadcast function, because in broadcast function, before we send out anything to all the users, what I want to do is go through the unordered map called table and look out any time. I calculate time now minus 30 minutes, and I will see if anybody's last activity is more than 30 minutes ago. And if that is the case, then we will remove them from the table. So to spare you the boredom of watching me write all the implementation of all the functions such as who, help, etc., I'm going to be doing this off screen and instead just focus on testing. Testing is actually, because we use a pipe, testing is going to be extremely simple in our case. I launch Tmux and then I split the screen in two, and on the left side we'll put in a simple echo into the pipe, and on the right side we'll run the chat server. And that seems to work fine. Perfect. Okay, so now that we've written this, let's go give it a spin. So we're still here in our terminal on VM370, and I wrote a simple program which then my friend Peter Jacob, which actually should be amended here, and Peter Jacob amended so that we can use a simple program, because we only have limited width of the line, right? There's only so much text I can write in as input, and so if a big part of that is going to be used to send a message to the chat server for the structure of sending a message itself, then there's only going to be this much text we can write. So to avoid that, I wrote the first implementation, and then quick and dirty, and then Peter Jacob made it beautiful and easy to maintain. So we invoke it, and when you invoke it without any options, the chat program will say you have to use either log on, log off, who, stats, or just the message itself. And what we do is anytime we want to send a message to, we want to work with the chat server, we send actually a message, tell root at relay, log on first and then log off, or the message. So very simple. So let's try this. Chat log on. Let's see what happens. And remember, this is going through several hops, in some extreme cases up to 5 hops for some people who are on the network. And okay, so we're logged in here now. Welcome to relay chat. And so now I can say relay who to see who's logged on. And this is still the same program we just saw before, and it should tell me who's logged on at this time. I assume it's only me. Oh, okay, so actually 2 people, the maintainer at Ireland earn and me. And so I can do the chat. Hello, anybody there? All right, so this is how it is, and if anybody feels like answering. Now the good thing about this implementation is that you don't have to actually launch a program and stay within the program to chat. Yeah, here it is. So now my messages are being sent to everybody who's logged on. So this works fine. We could maybe do the logout to be 60 minutes. But I think if people are not active for 30 minutes, they're probably gone or even logged out from the terminal. So, and if we send a message back to the users not logged on, has logged off from the terminal, then it's very easy to implement a loop where you send a message, then the system says there will tell the relay server the users logged on, which then the chat server will interpret as a message coming in, and we'll send it out again to everybody. And so this is how you create message loops. And so even though I did write a loop detector, it's still better, I think, to just log them out after not too much time. So after 30 minutes here, there seems to be nobody there. Let's see if we have stats. We should probably also do a help command, but I will do this maybe in the next few days. So we can see here total messages 28, total users 6. Okay, so up to 6 users have been logged on here to the system. So that's fine. That works well. So as you've seen here, it's really only about 200 lines of code to implement the chat server, especially if you do it in Go language. You don't have to deal with memory allocation and all that kind of stuff. So that's why I liked it. Now, of course, you're going to say, why couldn't we use an existing software? Well, I did look, and there was simply nothing. There used to be very famous Rex implementation of a chat server in the past running on a mainframe, but that is lost. I looked for it everywhere, and the gentleman who wrote it has also passed away. And then a second gentleman re-implemented it in Pascal language, and we contacted the person, and that person also lost the code to the chat server. So I'm sure it was way more sophisticated than mine. One of the features that I would like to add is have chat rooms, so that people can create their own chat rooms. It's not just one big chat room for everybody. And so I think I'm gonna do that over the next few days. It shouldn't be too hard to do it in the source code. I think it's just a question of saying add or create, and then have a second table, segment map maintained per room. Or we can also do it within the same, just add one more field in the user structure saying rooms that the user is logged in to, and then maintain it this way. There's several ways to skin this cat, but it would be nice to have a chat rooms implementation. Also, I would like to do maybe something that will give it access to from the outside of the network job entry protocol from the web, or even from a command line on Unix and Windows, so that people can also send messages with some kind of protocol, a TCP/IP based protocol, and so that we can kind of interface between the internet and HNET. So this all is really very, very simple to do. Not much there in terms of complexity. Yeah, you're going to say that this is not incredibly fast, but we need to think that this was the main network, the biggest network in the world before the internet in the 80s and early 90s. And so people just didn't have an expectation of a sub-second response time on these things. People understood that there's thousands of miles for the messages to travel, and sometimes people knew that there's dial-up lines. So this was very typical response time back then. It could take sometimes a day to send a file or a message to another person. And so this is, I think, a faithful representation and kind of a feeling how it was back then to use the BITNET, as it was called back then. And so HNET is very, very similar, even though it uses TCP/IP, of course, as the common transport protocol and not dial-up modems or leased lines anymore. But this still gives you the right understanding of the speed of things. So I can just say now chat log off, and I'm going to be off the chat server, and we can do other stuff such as okay, goodbye from relay chat. Let's see, sysop. I added, of course, already the announcement of the chat server to my sysop updates. And yeah, so also one thing I implemented was an auto upgrade of the relay command, because the relay command that I'm using here needs to be updated every time I add a new service to relay. So instead of distributing the updated relay command, which is itself also just a rec script, instead of having to send this all the time to all the users, now people can just say relay sysop, and if there is a new version, it will be announced there, and then all you have to do is say relay upgrade, and once you type relay upgrade, what the server is going to do, send you, as you can see here, the first time you have to do it by hand, but after that, if you have the latest version, anything after version 1.0, you just say relay upgrade, and then you're going to be sent the latest version of relay to your reader. And by receiving it on the reader, you can then just go here, as you can see, and just type F9 for receive, and this is how easy it is to get the latest version. So as you can see, we have some advanced features such as self-upgrade, news to all the participants, gateway to BBC News, NPR News, stock quotes, Bible, a daily Bible study for people who are so inclined, weather, and many other things. So so far I've implemented, I think, about, as I mentioned, maybe 40 or so services, and anytime that I think of a new one, I'll just, within about half an hour, it's up and running. So I hope you had fun watching me writing a new relay service, this time in Go language. And if you have any questions, please post them as comments below this video. Let's see how many likes we can get on this video. It would be great to get to 500 likes. And if you have not subscribed yet to the Mainframe channel, then now would be a good time to do it. And see you soon again on this channel. Thank you.